Hello and welcome back to building a Flutter game using no libraries, except we're building the server, so we are using libraries. We basically were in the middle of packing and unpacking a tile position, including the point and the fractional point that it requires, in order to, when we define our proto data types, we wanted to basically store the data very efficiently in order to minimize the amount of data that has to go across a wire. So if we always know that our integers are never going to be uh, needing 32 bits, right, we might then pack two integers into one. So that's what we were working at, except that it did not work exactly. So we'll figure out in a second why this is not working, and we'll go step by step. We'll look through the code that we have here, and we have a TilePosition, and we kind of realize this is not returning back. So basically, when we do a round trip, right, when we pack it and then unpack it, we should get back the same TilePosition we had before. We are not currently. So what we'll do is we kind of take a step back, and first we are going to try to pack a point, just a non-fractional point. That's the easiest case, and then we'll try to figure out why this is not working. So let's just create a point, and we say 1, 2, and then we say the packed version is point.pack, and then we'll basically just print out the and then we unpack it again, right? So then we unpacked equals pack, basically point dot unpack the packed point, and then we'll basically print both versions here. We know what it should be, so let's see. So we get instead of point. Okay, first of all, we need to obviously implement toString here. So let's overwrite toString. How can I maybe? Yep. All right, good. All right. So that's good enough. Let's put an extra space, makes this more readable. Okay. So now we got 1 and 2 and 0 and 4. Definitely not exactly at all what we're expecting. So let's think about why this is not working. Can we maybe print xy.toString to radix string? Okay, so we can actually print this in binary. So let's see actually what we're getting here. Oh, okay, we're missing a parentheses. All right, so we're getting 1, 0. Why are we getting that? So let's just first of all look how we're packing it. So it seems weird. I mean, are these maybe not 32 ins? But I thought they were. Let's print x. So x is 1. Y is 1, 0, which makes sense. I'm going to try one thing. I'm going to change. So I'm going to have a static here, a static const that says shift, and we're going to make that 8 instead of 16. So we're going to make sure we shift the same way, obviously. So now we're going to shift only to. Yeah, so it is definitely a 32-bit one. Otherwise, I'm wondering what I'm doing wrong here. I think we have to go step by step here and try to figure it out. So, so we're gonna have an intermediate right? Final x shifted, right? Intermediate thing here, and we print that out. And actually what we're going to do, is there a way to say, kind of want to add something. Not trim, the opposite of trim, pad left, okay. So you want to pad left, we want to make this, this one we want to make 30, let's make it all 32, and we want to put a 0 there. Alright, so I mean that looks correct, kind of. I mean that's, yeah, but we didn't do anything yet. So x shifted, so what we're gonna do, we just print all the different x shifted, print everything out as we're doing it. So we shifted x over, so x was what? X was 1, so we shifted that over, and that's fine. So we shifted that here, and now these are all zeros. Good. Oh, we can't do plus. We need to do and, right? So basically, okay, so let's like take this one, right? So we shifted this over now. This is where now x is. So in order to get y in there, we need to do this. Or we need to keep that. So we need to keep that, right? And then we need to also end it with 1, with y. So y is 4, I think. So something like this. And then basically what we'll get back is the string that has, so we get this string back, right? So we can just say that we're going to so the mask is this one. So we can basically take the shifted mask, and we basically say this is like our mask, and we shift it to the right, whatever the shift is, to the left, right? So that means that now we have and actually, you know what, we don't have to do any of this stuff. What we can actually do, we can say we don't do this. If you look at that, how do we, right? If we have this thing and we want, and we have something, and y is basically this and that, right? That's our y. We can say or. So if either one has a 1, then pull the 1 down, and now we get what we want. So we're going to do an or. And so for now we're going to just, so now we can actually inline this again, and now we're going to just print out the xy that we have and see what that brings us. All right, so now we're getting what we want, right? And now we can see we're starting to get some closer result, but that's probably just an accident. What we need to do now, we need to actually fix this here. I think there's probably just a mistake here. It seems like y would be that, and then x would be that. Except we need to do it after. So y is what we put in last, right? And then x is what we get out when we shift it back. So that's the only difference we had here. So now we're getting the point that we wanted. Okay, so we fixed that, which is nice. Now basically all the mistakes that we made up here, we also made down here. So we just have to fix them here. Instead of doing the add, we have to or, and then the This is actually the y, and then this is the x. And now actually we should get back the tile map. That should actually work now. So I'm so confident that I'm just going to leave this code, and I'm just going to do this, and I'm going to see. And yes, we're getting the same tile map back that we had before, right? And now to look back at like how we are able to pack this, right? We basically have two packed points. One is fraction, one is not. And I wonder if this actually makes a difference if we store this as a so okay, so let's then start with negative ones, but in a second. But basically we have UN32 and an int32 to store all that information, right? Which is really nice, really small. And again, all this is kind of hidden from us with the pack and unpack methods, which we'll just add to these data types, and then we don't have to worry about it anymore. In our game, we just call it, and we never have to do this detailed stuff again, ever. So what I wanted to see is, what if I put a negative one? So this one was not considering, so this actually works still, right? Because I mean, like we're not relying on any sign bits. We actually just. But the weird thing is, like, what if I print out? So what I'm going to do is I'm going to print 2.2 regex string. What's that does? That's 1 0. And then if I do -2, it should have some sort of a sign bit somewhere. Oh, it's -1 0. Huh? Okay, so but that doesn't help me. I need to know how it gets actually represented under the hood. But I mean, so let's try a negative here and this one also. Okay, now we have something. So we have a packed fractional point is out of range for an unsigned bit. Okay. So, but exactly there we actually need it. So actually now we this is good because we finally got the error that we wanted to verify if this actually matters. So in the packed point, we are assuming that it doesn't really matter, right? The thing is though that we can't store quite as many values or high values in there. So let's just say highest, largest uint 16 that we can store. That would be 65,000 something. But if we do a largest int 16 that we can store, that's like a 32. That's half, right? Obviously. So we just have to figure out if we ever have more than 32,000 tiles, like columns of tiles and rows of tiles, right? Because if we decide that the tile map is all zero based, so we never have really anything negative. So we make this actually uint, but the fractional point, right? Because that can be inside the tile map, right? So if you're here inside the tile, we can be over here. So that's a -x, right? So we need to have that negative, or at least like signed. So now we should actually be fine. Oh, we need to regenerate, obviously. So let's regenerate. Okay, and let's go back and run this. Okay, see that's the problem right there. Now we're getting. Now this is interpreted in weird ways. So basically what we need to do is we need to maybe somehow, let's see how we do. So the fractional point. Yeah, because what happens when it gets Yeah, we need to basically make this uint, and we need to make our fractions work ourselves. So we need to convert everything to positive, and we need to add a sign bit ourselves. I think we may get overflows and all these things, but we'll live with it. We're never going to have that many tiles. So basically, what we're going to do is we're going to go back. Right. So basically, now we have a negative number that we're trying to. So this is out of range, right? So we need to remove the sign. So basically, what we're going to say is. What we're going to say is this: in our fractional point, since we are supporting signing, we're going to say when we are packing it, so let's call it S and S. So, and then we say signed sign X is basically if S int X is smaller than 0, that will be basically basically what we want to do is we want 1 0 0 0 4 8 12 16. So we want to set this bit over here. So what we're going to do is we're going to go back here and confirm that that is it should be something like, yeah, I have no idea actually what that number would be. So we'll see really quick what that is. So our number is basically is this, right? Except without all the spaces. That's our number, and that happens to be that. So that's almost like the highest one that I have, right? So it's very close. It's actually weird. Oh yeah, that makes sense because they need that sign bit. So the largest number they can represent is basically this one 1 1 1 1 1 1 1 before the sign bit has to be set to go one higher, right? So if we do this, var I don't know, x equals this one, but all ones. So we have 0, then 1 2 3 4 6 7 8. Oh, sorry, I can't count. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Now that should be exactly that highest number, right? And now if we want to add 1 to that, right, and then we'll show that as to string and as binary, then that's exactly the number. So that's why they can't go higher if it's signed, because they need to reserve this one bit to be the sign bit, right? Makes sense? So, but now we have n, and then we're going to do toString. That's the one we want, and we're going to do the hex version of that, which is 800. Okay, that's interesting. Would not have thought about that. So so this is going to what we're going to put. So we're going to make that also a constant here, and because all this depends on the masking factor. The mask basically has to do with where the sign bit is, right? Sign bit equals, so we do that. So if sign x, so we make it 0, otherwise we'll make it the sign bit. The same we'll do for y. If y is so, then we add that, and then basically we'll say final int x is basically our sign in X, but the absolute, right? So that actually removes it. So basically, if you think about it, if we have a number like, I don't know if JavaScript will allow us to do this, but if you have a number that's negative, yeah, it puts a minus in front. But basically, this thing already has now a signed bit, but it will most likely be since it's 32 bits, it will be much higher, right? We can't use that. We actually remove that sign bit, and then we'll apply our sign bit. So I think we have to OR it. No, we don't have to OR it. So if it's 0, it will just, so it has to be end. No, hold on a second. Yes, if it's 0, yeah, we'll just say 0, right? So basically what's happening, so let's do this at a smaller scale. So let's just say our number is this now, right? And we want to add a sign bit. So this is our sign representation. Now imagine that there are 3 more of those. So this is our sign bit. So basically, if we OR it, we say, okay, if either one has it, right? So now we have 0, 1, 0, like this. So we get this number, which is basically the same as this, except now it has a sign bit set, right? So that's fine. And then int y will be the same thing. Int y is signed int y, move the sign bit, and then we'll sign it again. But we'll sign it as like a 16-bit integer. And so now we should get this. So I'm going to print again xy.toRadius string. Okay, so now let's see what we get. Okay, where are we? Okay. Is 0 or the sign bit, 0 or the sign bit. Okay, let's see. So now we're getting a signed here, and yeah, it's hard to tell like what's going on here, but it looks like we're getting some signing going on. So obviously now we are not unpacking this correctly yet, but at least we are not getting an error anymore. So when we're unpacking it, we have to do something the same way. So how do we figure out if it has a sign? So sign bit, right? So basically we get y and x, but we can't use y and x as they are. So actually here we have a rounding error, and we're getting almost the right number out, but it's positive now. So let's think about this. So we have the, actually I want to make sure we get this right. So we're going to print these. So we're going to do x. X is going to be so hold on. X is going to be this. To radix string. So let's do the radix string first. Okay, and then we're going to slice something. So we're going to slice. We're going to slice the first 16. That should be x, I think. Yeah, that's x, and then the y is basically bin dots. We take the last. This thing should be something like this, and then we go up to 32. Maybe that'll work. Something along those lines, and we'll find out if this works right away. Okay, so it doesn't like, well, it has to be xy. Okay, it doesn't like that either. What's going on? Slice. Not defined. Is there something? Oh, I guess I'm thinking JavaScript. There must be something like substring, and then substring start index 16 and end index. It's actually 31. and the end index here should be actually 15. So we get x is signed. Let's see if this is correct. It's not correct at all. One thing that I'm wondering is like, where are we actually? Are we already applying the factor? That's fine. So actually, that's what we need to do. So this would be something. Okay, so y is not signed and x is signed. Is this correct? Doesn't seem correct. So we're actually sending in. So this is the top position we're sending in. Y is negative, so it needs to have the sign bit set. So somewhere we're setting the sign bit on the wrong thing. So the signed x is x times the factor floor. Signed y is z. Okay. Then we're saying that if signed x is smaller than 0, we're doing it the other way around. Okay, so then we need to use a sign bit, and that's why it's actually reversed. Otherwise, we need to do 0, right? Okay, so let's see this now. And now value not in range 31. Oh, we need to pad it also. Dot pad left. Because you want 32, right? Because now x is no longer signed, so now it's not full. Okay, so now we're getting what we want, and we're getting almost the right thing. So this is correct. We're getting a signed y and we're getting an unsigned x. And then when we unpack it, that's when we have to take into account our little sign bit. Well, this is actually not super easy. Probably there are libraries for this, but again, this is kind of fun. I want to use a gRPC library, but I don't want to use a library for everything, because otherwise we'll learn nothing. So now what we have to do, we're busy getting y and but this is not what we need yet. So we had s u and x, and then we have the u and y, and then we have the this has, I don't know what we would call this. It's actually an int, right? And then basically we have to look if so here's our sign thing, right? So basically final signed x is basically, so what we're going to do is we're going to see, so let's just say let's just again make this smaller like this. So this is our sign bit thing, right? And so now what we're going to do, we have if it's not signed, if our number is not signed, let's say this is our number. If we end those together, right? If we end them together, we get 0, right? Right? But if our number is signed and we end it together with exactly the sign factor, right? The sign bit thing, then we'll get something that is exactly the sign bit thing and is basically greater 0. So what we can do is x is x signed is basically saying that end x and the sign bit is greater 0. And let's make sure we do this first. I think it's like that, but so when y sign is like that, and then we can say that final x equals x signed, then it's basically minus int x, otherwise it's int x, and y has the same thing. If y is signed, then it's negative, otherwise it's what it was. And so then we have what we needed. And then we can convert back to double. So up to here it was all integers, and then it's back to double. Let's see if that works. I mean, you get the signing. I just don't understand why it's multiplied by 2, pretty much. I mean, we're getting pretty close. I mean, it looks like it's actually not really double. it's something different. Oh, this is okay. Actually, what I'm going to do is I'm going to debug through this. So, let me make this smaller. So basically here, let's look at the variables. So x and y, we have them set like this. Now we'll step piece by piece through this. And let me just load on the shades. As you can see, I'm getting really sunny over here. Okay, so this should improve things immensely. So it's okay, yeah, it's yes, that's fine. And now y is that, okay, that's fine. Then sine x is 0, sine y is basically that, okay. And then int x is that, and okay, here we have, okay, this is, since we're now applying the sine, or this is a question, are we applying the sine bit correctly? So int y, I mean, obviously, like it reads it as that actually makes somewhat sense, because we're applying, it's still interpreting it like a 32-bit number, and we just added a bit there, right? Right, so it basically, like the fact that this prints that number shouldn't really concern us too much, because it basically doesn't understand that we are thinking of this as a sine bit. It still thinks of this as an int 32. But it's actually what we're trying to do. We're trying to make it in 16. But Dart doesn't understand in 16s. It just understands ints as a certain way. So now when we basically added that sine bit, it's some extra one, and therefore it interprets it as a different value. What I'm wondering is, like, so we're basically adding like a 2 to the something to this number. Okay, that makes sense, actually. And then we step through here. So you can see xy is also interpreted as this huge number, because it doesn't understand that we are actually trying to right, we're trying to do something different with it. We're trying to interpret it. We're basically packing 2 ints in it, and it now sees just that one int. That makes sense. So now the bin is that, right? It's kind of what we saw. Okay, fine. So then basically when we unpack it, maybe that's where the problem lies. So let's go here. So we should get our number back, yes. And then so this is perfect. We got the same number back that we saw, right? This is the same number. Oh, we need to remove the sign bit. Yes, that's it. We don't remove the sign bit. We keep the sign bit and we just, right? That makes perfect sense. So we need to actually not only apply a negative, but we need to basically remove our sign bit. How do we remove our sign bit? We need to mask it out. So what we need to do, we need to, so this one was basically, so, right, so this one was basically 1, 0, 0, 0, 0, 0, 0, da, da, da. This is how we apply the sign bit. Now we need to have a number that's the opposite, right? And then if we end this with any number, like say we have a number, I don't know, like this, and we're running out of time here a little bit, but I want to get this finished. If we have something like that, and then we end this, we basically, if it's signed here, right, we'll lose that sign because we're ending it. So we need to figure out what that number is in. It should probably be just one lower than what we have there, but we're going to confirm this in our node rebel. We're going to say our number is 0b. That's what we're trying to get. Oh yeah, we need to right, name it. And so now we're going to do toString. I bet you it's going to be, oh, we'll see what it is. String, and then I'm going to do 16. So yeah, that's what I thought, 7FFF. So we're going to have an unsigned bit, and that's going to be 7FFF, which is just one below the signed bit. 111. Okay. Now all we have to do here, we have minus and the unsigned bit. Let me do the same here. And the unsigned bit. And now things should magically work. So let's see. Well, we don't want to debug anymore, so let's just run it. Yes, so we get a rounding error, right? Which makes sense because we're basically flooring things. But we're not worried about this. This is enough precision to figure out where we are. Yes, so we got it figured out. I'm very happy about that. Before we finish the stream, hola Julian, I don't know if you're still here, but thanks for saying hello. I'm just seeing this now in the chat. Thanks for joining, and thanks anyone else for joining who joined. We are now in a really good spot. There's no code to check in yet because we are just spiking. I hope to not lose all this code, right? But we'll pretty soon work this into our main project. So for now, we are almost at a good point because if you look at the what the player has, the player model, right? We have a TilePosition and we have an offset, which is basically just it's a fractional point. We already have that figured out. We have a double, which we will maybe just multiply with something and pack it like that. So we make something like a pack double with precision, whatever. And we already figured out this can just be flags, and then we're done. And so then we can at least have player models be sent back and forth. And so that should be enough to do like a little test. Like if we say rotate, then the player actually starts rotating and it keeps rotating, or if we send like a velocity increase and the position of the player keeps updating, we should then get the messages. So I'm very happy. We're in a very good place. This was the hard stuff, but this will save us a bunch of not only space on the when sending these messages. They will not be smaller only, but it will be more efficient. Also, obviously, if you're playing this game on a mobile network, right, you don't want to lose all kinds of data just because we couldn't figure out how to properly pack and unpack specific things. So at this point, we are really good, in a good position. And that will end this episode here. I'll be back in about, I would say, in around 7 my time, so that's 9 p.m. Eastern. In about 1 hour and something, we'll be back for more. So join me. I hope to see you there, and I'm signing off. Bye bye.